going to go over the relative energies of orbitals. From low to high energy, the lowest energy orbital is the 1s. One energy level above that is 2s. Then there is 2p, and there's 3 of them, like we said in the last video. Then there's 3s, 3p, then there's 4s, and then actually we go to 3d. 1, 2, 3, 4, 5, and then 4p. 1, 2, 3. We're going to start doing electron configurations. And what we do is you look at the number of electrons in an element and you give the probability of their locations when they are in the most stable state. So one thing, electrons fill orbitals from low to high energy. That means the first orbital to be filled will be the 1s orbital. So let's look at the example of helium. If you look on the periodic table, helium has 2 electrons. And I should also say that there are 2 electrons per orbital. So you can have a maximum of 2 electrons per orbital. Helium has 2 electrons, and we will represent electrons with arrows. So if I can fit 2 electrons in the 1s orbital, I'll represent one with an up arrow and one with a down arrow. And that is because they have opposite spins. So this means that there are 2 electrons in the 1s orbital of helium, and they have opposite spins. Look in your book about Hund's rule for that. Let's do a more complicated example of filling electrons into orbitals. Let's say that we have nitrogen. Look on your periodic table and you will see that nitrogen has 7 electrons. So 2 of them can go into the 1s orbital, and 2 more can go into the 2s orbital. That means I have 3 electrons left, and there are 3 2p orbitals. So they will go 1 into each orbital, 2px, 2py, 2pz. All 3 of these orbitals are of the same energy level, so it doesn't matter where you put the electrons in first, but you will half fill the orbitals before you start pairing up electrons in them. But I go from low to higher energy.